In this video, we will learn about triadic closure. In principle, if two people in a social network have a friend in common, then there's an increased probability that they will become friends at some point in the future. Given three people, A, B, and C, if A and B are friends, B and C are friends. There is a high possibility that A and C are friends or will be friends. If each person can be represented as a node, three nodes form a triadic closure, as shown in the picture. In clustering coefficient graph theory, a clustering coefficient is a measure of the degree to which nodes in a graph tend to cluster together. In other words, the clustering coefficient of a node A is the probability that two randomly selected friends of A are friends with each other. This is a social network metric to measure the prevalence of triadic closure. Now, given that V equals node and KV equals degree, and NV equals the number of links between neighbors of V in a graph. We can use this now in the following equation. The clustering coefficient of any node V will equal 2NV divided by KV times KV minus 1. We can solve a problem now. Find the clustering coefficient of a node V using the graph below. I will give you a moment to try this problem. Now on to the solution. By looking at the graph, we first need to figure out NV, which is the number of links between neighbors of V. At this point, we see 4 nodes that are neighbors of V. Therefore, NV equals 4. Next, we need to figure out the degree. And we see that V is actually connected to other 2 nodes. So, KV equals 2. Now we're ready to plug in the numbers into our equation, which will give us 2 times 2 divided by 2 times 4 minus 1 equals 4 divided by 12. It can be reduced to 1 over 3. This fraction is the possible of interconnections that we have in the graph. This calculation is done. We have solved our problem. Future problems will require you to find the clustering coefficient of a graph. In order to do this, you need to find the average of all clustering coefficient of every node in the graph. Thank you.